Thank you. Can you hear me? Yeah, perfect. And if we can put up the slides, perfect. All right. We have never been equipped with more technology than today. First, we all got smartphones, then smartwatches, then earphones. And soon, as we all know it today at AWE, we will all be equipped with augmented reality glasses. But the way we interact with these devices remains limiting. It's almost disrespectful of our potential and their potential. Existing human-computer interfaces have not been designed for the wearability that we now require. They require us to have phones in our hands or use controllers. Or they require dozens of sensors that only big headsets can handle. They should not. What if you could control your device without even touching it, almost magically? And what if that technology could be integrated into our small and ever-present wearables, like our glasses or our wireless earphones? Hi, my name is Yacine, and I'm the co-founder and CEO of Wisear. We are a bunch of data scientists, product and hardware experts who love to tackle big challenges to make your life easier. And we are very convinced that you shouldn't be enslaved to the device that you're wearing. You shouldn't have to struggle to find that tiny little button on these 250 euros earphones of yours. And you shouldn't have to use 2 controllers or even dozens of cameras to just be able to open your favorite app on your AR glasses. Now, what we believe is that your human-computer interface should be seamless, voiceless, and touchless. And that's why we are building what I believe is the very first neural interface that can sit into any wearable, starting with wireless earphones. So what's a neural interface? It's a big word, a big scientific word. But I'm going to try to make it simple right here. Neural interfaces are the most natural and intuitive way to communicate with technology. Neural interfaces empower us. They are the most direct path between our intents and how they translate into the numeric world. If you think about this, the way we act today is kind of crazy. We have to use keyboards and mouse and monopolize the most important part of our body, our hands, our voice, to communicate our intent to these controllers. And these controllers are then, in turn, in charge of controlling the gazillions of other devices we use every day. They should not. Sorry. If you think about this, your body acts like a power source. Every time you think, you move your eyes, you move a muscle, your brain sends electrochemical messages through your body. Now, what's interesting is that if you place the right sensors at the right location, you can capture that bioelectrical activity. And now what's even more interesting is that if you add the right dosage of neuroscience, signal processing, and AI, you can actually clean, observe, and find patterns through this bioelectrical signal that you can then turn into controls. What that means is that your body now is the computer interface. We can read your brain, your eyes, your facial muscle activity, and transform it into controls. You don't need to press a button. You don't need to click. You don't need to punch a key anymore. You can simply blink, peer, or clench. Actually, maybe I don't even need that clicker anymore. I can control my slides hands-free, voice-free. I can go to the next slide. or to the previous one. So, sorry for that. So seamlessly, it's like magic. So what I'm wearing right now is the latest iteration of our prototype. This is our demo kits, and I'm happy to say that we have a couple available for sale or for testing. If you want to test it yourself, you can come to me afterwards. These are the very first wireless earphones that can decode real neurons using digital neurons. I'm kind of happy to say that this is a much better iteration than what I used to wear in previous conferences or at the office. As you can see, these were slightly bulkier. I'm also not too ashamed to say that we have one of the most dedicated teams in the world, not hesitating to shave their heads to try new type of electrodes or wear bulky and not comfortable headsets for multiple hours just to make sure we collect the right amount of data to bring the algorithm to the level you deserve. So for those of you that may know us or that have known us for the past few years, we have been claiming that the right type of human-machine interface for the future, for augmented reality, would be one that would use micro gestures for selection, that would use eyes for navigation, and that would use speech for complex commands. That might remind you of that small company that did a big announcement with that type of human-machine interface back in June. Except that they have to use 12 sensors on a big headset. We try to do that with 3 electrodes on your earphones or on your glasses. So I've shown you right now how these controls can help with very utilitarian use case, like me controlling my laptop, giving you a nice demo and changing my slides. Now let's project ourselves a little bit further in the future with a VR headset. My colleague right here has to use his controllers to play, pause, or go to the next video. Thanks to our technology, he can drop these controllers, do whatever he wants with his hands, like eating popcorn or laying down or whatever, and play the video by simply doing a double clench of his facial gesture or a triple clench to go to the next video. But that's not it. As I said, 3 components: micro gestures for selection, eye for navigation, and speech for complex commands. Over the past 12 months, we brought a second generation of controls, still using the same sensors, still using our neural interface, and still from your earphones. We built an eye movement detection. With the earphones I have in my ears today, we are able to detect if you're moving your eyes horizontally, to the right, to the left. This is the very first iteration of it. The roadmap for us is pretty clear. For the next 12 months, 18 months, 12 months for the investors, 18 months for real, we will expand this type of controls and this type of detection to not only cover horizontal motion, but also vertical, and improve the precision and accuracy until we can match the UX and UI needs of our AR partners. Again, because a picture is worth 1,000 words, here is a quick demo of me on our rooftop in Paris, one of the most amazing rooftops you can see, actually controlling an AR UI using my eyes activity. So right now, I'm opening the navigation app with a quick eye gestures. Because it's sunny outside, I will want to select the biking option. For that, I'm going to look to the left first, and then doing a quick eye swipe, I'm going to open it. Everything is done through our earphones. No camera is involved here. As I'm riding my bike and getting the instruction as a picture-in-picture on the top left corner, I'm actually going to go and check the notifications without having to leave the handlebar. So I'm going to open the notifications. I see that Emmanuel Macron just tweeted about us because he really loved what we're doing. That's great, thanks to him. Tim Cook also liked our tweets. And now I want to answer my co-founder, Alain, telling him that I will be there in 5 minutes for the meeting. So I'll look to the left. I do a quick eye swipe. And now, again, I'll tell him that I'm going to be there in 18 minutes, which is not a good sign if the investor meeting is in 5 minutes. But, you know, you have to do what you have to do. And again, doing a quick eye swipe, I can select it and go back to the main menu. Everything happens just using eye gestures. No hands need to be involved. No voice needs to be involved. And this is just the first generation of our controls. Now, as I said, facial microgestures for selection, eye for navigation. What about speech? We also are working on something here. It's much more researchy, much more early stage, but I will be happy to show it to you for the very first time today. So at Wisear, we have been working on something that we call silent speech. It's kind of the most private way to use voice commands ever. It's a mix of our neural interface sensors and additional sensors that we leverage through sensor fusion. At the moment, in 2023, we are able to detect 20 keywords with it. And the way it works is that instead of having to pronounce the words, I can just mouth them. So instead, if I want to tweet, for instance, to my AR glasses, Wisear is an amazing company, watching the most impressive demo ever at AWE EU, I can simply do, and that's it. And our earphones would be able to pick it up. Now, I understand that you all don't have your Wisear phones ready yet, so if you want to tweet or post on LinkedIn about us, these are our handlers. I will add them back at the end of the presentation as well, because it's also a bit of a marketing thing right here, not just about what we do. So the roadmap here is pretty clear too. We currently are able to detect a couple of keywords, and we're going to move from detecting keywords to detecting phonemes, out of which we will be able to reconstruct any word that you may want to say tomorrow. Again, because an image is worth 1,000 of silent words. This is Cleo that's going to be presenting
I'm Cleo
our
from
technology.
Wisear, and I'm currently wearing our latest device. It can detect when I'm saying words silently. Let me show you how this works.
Okay, and again, this is just the V1, but as you noticed, she didn't have to vocalize any of these words for our algorithm to detect it. In case what you've been seeing so far wasn't convincing enough, we want to add that we've been thinking about AR manufacturers and any manufacturers from the get-go when we started this company. We first decided that we would only leverage off-the-shelf components. What that means is that to add our neural interface sensors and analog front-end to any device, be it your wireless earphones or your AR glasses, the total BOM cost is below $5. What this also means is that we have been working tremendously on making sure that our AI algorithm would be as low power as possible. We only require 6 milliwatts and less than 30 kilobytes of RAM to run the eye gestures and facial microgestures detection algorithm. But we believe this is kind of required if we want to be the human-machine interface of the future. If we want to be the most unobtrusive, instant, and inclusive human-machine interface in the world. Unobtrusive because, as you noticed, it's pretty much every control we've built are meant to be super discreet and very private, so that no one really knows what you're doing, because no one has to know what you're doing. Instant, because we've been working on optimizing and improving our signal processing and AI stack so that our algorithm would take less time to run than for you to go and press any button. But the part I'm the most proud of, to be honest, is how inclusive our neural interface is. It doesn't matter if you have a very strong French accent like I do and your voice assistant doesn't really understand what you're saying. It doesn't matter if you have limited hand mobility. You would still be able and allowed to control your everyday devices thanks to our neural interface. For the past 12 months and for the upcoming years, we have been working on making sure that our controls are compatible with the most XR ecosystem. Thanks to all our partners that are already trusting us and the ones that we may announce during AWE, we want to make sure that our technology is available to the greatest part of the population. So if this is something that's interesting to you, please reach out to me after this talk, during the conference. I'd be very happy to chat. Neural interfaces are for everyone. They work everywhere, and they work for anything. And with the advent of augmented reality and extended reality, we are very convinced that they are ineluctable if we want to provide the users with the right type of controls they deserve. Thank you very much for listening to me. Now, if you have questions, I'd be very happy to answer them.
Thank you very much, Yacine. And I have a microphone, and I will use it, so please give me a sign of hand. Okay, first row already. Please tell us maybe what's your name and what you do. I will hold it for you.
Okay. My name is Christoph. I'm with the Austrian Research Promotion Agency. So my question, well, this is really mind-blowing. Congratulations.
Thank you.
I talked to several scientists working on neural interfaces, but this is pretty cool. So my question is, did you try to wear that device during the night to record your dreams or maybe even keywords coming up in your dreams?
That's a good question. So first of all, I don't think we've reached that level of comfort where I would be fine wearing it at night. I would say that I don't think we would have the right device for that at the moment, maybe in the future, but recording sleep stage data and even like what you would describe as almost thoughts in the future is something that at the moment is very hard to do already with big headsets with multiple sensors. If not, like maybe you just need invasive sensors as well, like what Elon Musk is trying to do. So we're not to the point yet where we can do it. I'm not saying this will not be the case in like 3 generations of devices once we have millions of people wearing our device everywhere and we have a lot of data. But at the moment, this is not something that we would be able to do, even if we were to wear it during the night.
Thank you very much. And next question here. Please say your name and what you do.
My name is Vanessa Leung. I'm a senior scientist at the University of Applied Sciences in St. Pölten. Thanks very much for the great talk. My question is, what is the training period required for these devices? You know, what kind of calibration is required, that kind of thing, in order for this to work?
That's where the magic happens. We've been working on like having all our technology being calibration free. So we did record a lot of data though. So I think we've had like so far close to 500 people coming to our office. We have like close to 500,000 data points that we've been using for training both the facial microgestures and the eye motion detection. So at the moment, we don't need any calibration. This is something we're going to be adding this year, but more as a way to improve the performances, the same way that, you know, when you get your voice assistant out of the box, it works. But if you want to train it on your own voice to make the performance better, you can do it too.
Next question here.
Okay. I'm Giel Zwager from the Dutch Ministry of Defense. I'm wondering if the silent speech is language independent, or is the dependency within your code, or is it from other parties? Can it work with other parties?
Can you repeat the question? I'm not sure I got it.
Is the silent speech, is it language dependent? And where is the language dependency programmed? Is it in your tools, or can you attach it to other tools from third parties?
So unfortunately, at the moment on the silent speech, I cannot share too much without being under NDA. What I can tell is like at the moment it's language dependent because we trained it on specific words, right? The rationale is that tomorrow, as we move towards phonemes, we will have way less language dependency as long as we can cover all the phonemes across all the languages. Of course, it might take a long period of time, but that's where we are right now. But happy to chat further after the call, after the presentation, if you want.
Thank you very much.
Next question over there. Hurrying up. All right.
Thank you. I'm Sam. I'm a technology analyst at RDTechX. I'm interested in how difficult the facial gestures are to learn. I don't know if it was an earlier prototype, but some of them look like relatively large gestures. Have you seen much sort of the learning period for new users of the device?
Yeah. So there are two components, right? There is how intense the facial contraction has to be for us to detect it. And on that, we've spent a lot of time improving both the hardware and also the algorithm so that we can really detect micro gestures. I don't know, maybe, I don't know if you looked at me while I was doing it, but like I'm pretty sure it's invisible from where you guys are. So that's the part that we worked on. Then the second question is like, how do you teach people how to learn new gesture, which is always a very complicated thing to do. This part is also something that we spent a lot of time on. We have kind of this onboarding tutorial that has like 3 steps that we've gamified a lot, and that basically helps people like kind of learn the gesture much faster than what we used to have, where it was like a bunch of different screens that they had to look at and text around it. So we today have a learning period that's below 30 seconds on the gesture, and then people can use it. I mean, we've had people coming back even 6 months later, putting the earphones on, and like, you know, they can just use it right away. So the learning seems to be staying, I would say, over time.
And the last quick question.
Oh, yeah. Hello, my name is Stefan. I'm from Germany. We're creating VR trainings for safety issues. And my question is, how will you interact with VR glasses? Because it sounds like that you're competing with controllers because you got a different kind of controlling.
That's a fair question. To be fair, I don't think we can nor want to compete with VR headsets. I think VR headsets have like both the computing power and the battery power and the controllers, like the environment in which you are doesn't require as much mobility as what I think augmented reality glasses have. So to give you an example, like one of our partners is DigiLens. DigiLens is doing AR glasses for industrial workers, in which case the situation is very different because they are wearing the glasses. They don't have controllers. They have both hands that they have to use on like a maintenance workflow or anything like that. And so in this case, having hands-free, voice-free controls like ours that do not matter whether or not there's a lot of noise around you is very important. When it comes to VR, and specifically after Apple releases their headset next year, I don't think we can really compete with any kind of a control that will be available to the user. Sure.
And that's it for Yacine Achiakh, CEO at Wisear. Please give him a warm round of applause.
Thank you very much.